Hello everybody, I'm so happy that I'm with you with a new video. In previous video we talked about how human understands color and now in this video we want to say that how we can measure color and express color in some numbers, in some digits, and reproduce them. So this is very important to measure colors. You remember from the previous video that our eyes understood colors by three numbers that they were for expressing red and green and blue, and with the mixture of them our eyes say that this color is red and this color is yellow, for example. So here how we can do the same to understand colors, to measure colors. I just want to tell you that there's an organization, it is called CIE, that CIE has provided a very interesting system that is kind of the basic and the most important system for expressing colors. And here you see the gamut that covers all the colors that you can find in nature. It is said that there are colors that even maybe you cannot find them in the world, but in this gamut you have them. So by this gamut, by this system um, that we have, and we have the outside light that is shining to the objects and you see the colors. Now let's measure these colors. So for doing this we need three important things that you see them in the formula. As you see, for example, we have a K on N, okay, that is the scaling factor. You have S lambda, I lambda, X hat, D lambda. Lambda is the wavelength for different parts of electromagnetic energy. So you have three functions of lambda. So here just I can, for example, here if I doesn't click, my a little freeze my laptop, new slide, I come here. So just let me remove the boxes here because I want to write with a pen. So I just close this. So let me come here and click here. It doesn't open for me. Depends, draw. Yes, they are here. So for example, just with black. All right, so we had the light distribution, that we want to call it I of lambda. We need another thing that was the S in the formula that you saw it, that stands for reflectance, that we call it S of lambda. And we needed the color matching functions, that they were X hat, Y hat, and Z hat. Okay, so in this slide you see that you need S, reflectance, the amount of the energy that is reflected from the object, from that color. You need I, that is all the light that you have and is shining to the object, okay? Part of it absorbed, part of it is scattered, part of it come to your eye. And color matching functions, that are the functions that CIE has defined to understand the colors as a human understands. So now, how to measure these? Okay, you need light, okay, a lamp, or a torch, or just a projector or the sun or something. You need an object, and you need a spectroradiometer or a spectrophotometer, all right, to record these data for you, light distribution and reflectance. So after measurement of the reflectance with a standard weight, you will measure the light distribution, all the light distribution that you have, and we can find X, Y, Z that are for expressing colors. In future videos, we will talk about how we convert this XYZ to RGB and other systems, okay? But now just you need to know that XYZ is something like RGB that we have, that with these 3 digits you can reproduce your color anytime, anywhere. So for this video, you will have some files that I have put them on my GitHub, and just you can download them, and you see X hat, Y hat, and Z hat are here, and you have some responses and the Y distribution in this file, and you can download them and do this exercise at home for just practice and for measuring some colors. All right, so the link of this directory, I will put it in the caption of this video, and you can easily reach them and download these files. So now we need to call these files and write the code on Python, and just calculate X, Y, Z. All right, I also can show you the files that for the functions, so you can just open them and you have them here. For example, for 2 degrees, you see for different wavelengths you have the value of the function. So for example, if I show you the X hat of this function, you will have an idea about it. It is interesting. Okay, you have this color matching function. So this is for X. For Y, it is different. For Z, it is also different. And for color checker, so yeah, you just open this file and you see that the names of the sheets are French, okay, but you just need to write the names correctly to be able to call them from Python, but everything will work well. So you have, for example, FOI, it is sheet 1, and this is FOI 2, that is like sheet 2, and for each sheet you just need to have the first column of the data. That is enough. And also for in the last sheet you have the information of this color checker, 24 colors of this color checker that have been measured. So FOI sheet 1, you see that it is moderate brown, okay, and sheet 19 is the white, the complete light distribution that also we need for in the formula. So you have these colors and you have the white here. All right, so I close this. Now you know the files also. So I just come to Colab of Google. Just you can search Colab Google and you will have Colab, and it is free. So you can write your Python code here. So just file, new notebook, and so here now we can start our code. So first of all, just I need to upload the files that you need. So just they are on my desktop, and functions. So I upload all of them, and says that after you leave, so they will be deleted. This is okay. So I have my files here. All right, and now you can write your code in Python to read the files and write the formula and calculate the x, y, z. For doing this, we import numpy as np. I also import Pandas that will help us with the reading the tables and working with the tables. So after that, we need to just write the formula. For k, we just use 1 here for the scaling, and for d lambda you need to put 5, because in the files you remember that for each for steps of 5 nanometer the measurements have been done. If the steps were 1, we put here just 1. So let's upload, let's read our files first, and then we write the formula. So for example, I start with x hat and I say that pd dot read underline excel. So you need to write the exact name. All right, you can copy it also from here, for example by copy path. I can just put it here. You don't need all the path, you can keep it or you can delete it. I deleted not to be confusing. So this is the x hat that if I run it, so without error it was executed. If you want to see it, just I can write x hat here. You see that the data have been read like this, but the first line we don't need, we just need it from here. So we can say x hat that I location. With this function, just we can select part of our table. So it will be from 1 to 82 and 1. Okay. I write 1 because Python understands from 0. So 0 we don't select, and we select from 1. Okay, to 82. All right, and the first column 0, no, column 1. So now the data is okay. So I come here, I copy this to read y hat, and z hat, so you need to just change these here. And for example, here also I need to just change the y here, and the name is the same, but for the next one I need to change it to z2 dig underscore 05, and the rest will be deleted. So the same story, we need to select just the part of the data that we need. So I change this to y hat, change this to z hat, and here it should be y hat, here should be z hat, and the same story next. So after this, what we should read, we should read the white. Okay, so I call it I, as we had in the formula. So I say pd dot read underscore excel, so parentheses, and so apostrophe and the name of the file that I just come here and select it from here, and let me delete that part of it. Okay, we don't need it, so this is the name of it, and this reads all the file, and just I need to select the white. Okay, so the name of that was sheet 19. Okay, so that I told you that the name of it is French, is feuille, that I use that. So I copy this and I paste it here to change it for S, and so read Excel file and the same file, and for example feuille, that is sheet 1, that was a brown color. So the same story, we need to select the correct part of the data that we need. So just I say I here is I dot I look 1 to 82 and 1, and here it will be S I look and this part. All right, so now we have our data that is being called, uploaded, and selected. And after this, you need to write the formula. So first we write n, and after we have n, you can use it for x and y and z in this formula. Okay, so we have multiply of I and y lambda for n and the summation of the result. Okay, so I do this, and I forgot to say that we should multiply it by 5 because our steps of the wavelength is 5. So just I do this with multiply function. Okay, so I write, for example, n is equal to so np dot multiply. Okay, np dot multiply, so we needed to multiply y hat and I. Okay, so after this I need to so multiply np dot multiply this and 5. Yeah, all right. Okay, so after this multiplication, you need the summation of the result. Okay, like this. So this is n, this is ready, and after that, so x, y, and z, like this. I do the multiplication just 2 by 2. You can do with 3, however, just I do it 2 by 2. Maybe this is easier to understand and follow, but this is just the code that you can write it in a way that you like. So 1 per n, okay, that was the scaling factor, and you just need to multiply it. So first we needed to multiply, okay, multiply x hat and I, okay. So I come here, I say np dot multiply that result of this multiply and s, okay. And now you need np dot multiply of this term and 5. So this is x that now is ready, and of course we should apply the summation. So np dot sum of all of this. Okay, I hope that I didn't make a mistake for the parentheses. So, and for y and for z. So let me just copy this, paste it here and paste it here. So instead of x hat we should put y hat, and here z hat. Okay, the rest is the same. So let's print the result x print y and print z. All right, so let's execute. So fortunately there's no error, and we have these x, y, and z. So maybe you say that now with this x, y, z, how we understand the color and what is the color. So let's just check it on one of these websites. You just need to, for example, search for XYZ to RGB converter online and open one of these websites, okay. And so let's try the values. For example, 17.7 is for x. So 17.7, and we have 15.1, 15.1, and we have 8.9, 8.9. So you see that it gives you the RGB value that is correspondent to this, and this is the color that in the beginning we said that the color, the first color of that file that you have was brown. So you can just test them like this, and you can try with other colors also to see what result you will have. So by this practice, by this simple exercise, now you can measure color in the precise way, okay, in the very precise way, and based on the complete reflectance of the light from a color, measure and calculate the real color that you can reproduce it anywhere in the world. So to the next video. I hope that you liked the video. Please share with your friends if anybody may be interested. Don't forget to like and subscribe. See you soon.